Okay. Can you guys all hear me? Okay. I am recording this so that I can post it on Google Classroom for students that were absent first period. So I didn't record it first period, so they can if you're talking, but mostly they're hearing me. So you should make sure that you're not saying anything inappropriate or whatever. So, okay. Well, you guys can watch it too. So we have a couple people who are not here right now, so they might watch it as well for third period. But anyway, it will get posted in Google Classroom, and it'll say 6-6 comparing methods. So just to be clear, we will be having our final exam that will just be covering this material. It is not a cumulative final, and I feel like it's okay to do that because you have to know a lot of different things to do this. So you're demonstrating that you know how to solve equations and how to substitute into equations and how to graph by answering all of these questions. So your final exam is not going to be cumulative. It is open note also. So the idea of this page is that maybe this is the only page that you need to have for your notes. So on the day of your final exam, which will be the last day of school for third period, first period it'll be the first day of finals, but I'm going to collect all the notebooks at the beginning of class so that you start your test without your binders. Then I'm going to grade them, because it'll take me about a half an hour probably to grade everybody's binders, and then I'll give them back to you and you can use them. Does that make sense? Okay. The final periods are usually about 2 hours. So, I don't know. I can't, 25 maybe? I don't know.
Oh, let's go.
All right, so let's take a look at our 3 different methods. Now, you guys might have a method that you particularly like, but we're going to compare them today. So we have 3 problems that we're going to solve. We're going to solve all 3 of them in all 3 of the methods. So we're going to get the same answer in each row.
We don't have problems.
I just copied them. I just copied them with the copy paste thing. They're all the same problem. So, because when I zoom in, I can't see the equation. Like when I zoom into this box, I can't see it over here, but you guys can see it, so you don't have to rewrite it. Okay, so let's look at the graphing first. This problem, when I look at it, this is not a bad one to do graphing. Graphing is not usually my first go-to for solving systems, mostly because you have to have graph paper in order to do it. Otherwise, it gets really tedious. It's just not my favorite method. For some of you, you might like graphing, and that's okay. But if the numbers are really big, it makes it harder, that kind of thing. But they're already in slope-intercept form, so this one is easier than other methods might be. So I'm going to mark the first one in blue. What is the y-intercept? 3. And the slope is 1/1. So I'm going to go to 3 on the y-intercept. Then I'm going to go up 1, right 1, up 1, right 1. I'm going to put all these dots in here because it's going to make it easier for me to draw the line. And when I run out of space, I'll go down 1, left 1, because the negative cancels each other out. Okay, now let's look at the bottom one. Did you get that line graphed? Okay, so let's look at the bottom one. What is the y-intercept? And what is the slope? -6/1. So I'm going to go to -4 Then I'm going to go down 6, right 1. I run out of space, so I can change that by going up 6, left 1. And I'll get the same line. And we can see our point of intersection is right here. Our answers to all of these questions are points, so they should be written as a point. And to differentiate a point from just two numbers, you have to put it in parentheses. Yes?
When you say down 6 and whatever, do you start from like the middle point or start from the like up there?
I started from my y-intercept. So my y-intercept was -4. So I went down 6, right 1. Because this is -6. And then I ran out of space, so I have to do the opposite. So the opposite of down and right is up and left. So I went up 6, left 1, up 6, left 1. So that point of intersection is -1, 2. Now if I plug that in to my equations at the top, if I get true statements, then that is the correct answer. Like I put in -1 for x and 2 for y, and I do those problems. If they truly are equal, then that's my correct answer. We're going to do the same problem, so we're going to catch it if it's not right. But if you're only doing one, that's one way to check your answer and make sure you're doing it right. Any questions about the graphing? All right, let's move on to substitution. Again, I rewrote the equation, Eli. I rewrote the equation so that I can see it. But basically, I'm going to take what y equals and I'm going to plug it into the other equation for y. In order to use substitution, we have to have one of the variables by itself. It doesn't matter if it's x or y. It doesn't matter if it's in the top equation or the bottom equation. But if there's a variable that's not by itself and we have to get it by itself, you're going to look for one that has a coefficient of 1. So plug that in. You'll have x plus 3 equals -6x minus 4. I don't have to because there's nothing else there. If there was a number to multiply it by, I would, but since there's nothing else there, that's fine. Then we solve this by getting, I'm going to move the x's first. I'm going to add 6x to both sides. So I have 7x plus 3 equals -4.
I thought x equals -1.
And I think you're right as well. So 7x equals -7. You divide both sides by 7 and you'd end up with x equals -1. So then I'm going to take this equation. It doesn't matter which one I take, but I'm just going to take the top one because it's easier, I think. And I'm going to go y equals, well now x is -1 plus 3, so y equals 2. So my solution is -1, 2. Does that match what I got in the first one?
Yep. Yeah.
Any questions on substitution?
No.
Okay, now we're going to do this same problem, elimination. First thing with elimination is you have to make sure that your x's and your y's and your numbers and your equal signs are all lined up. Is that the case here?
Yes.
Yes, they are lined up. So, which variable do you want to get rid of? X. So that means we want to multiply this top equation by 6. That's up to you. You should definitely write down the next part, which is 6y equals 6x plus 18. And then the bottom is y equals -6x minus 4. Now we've set it up so that we can add them together and those cancel. So 6y plus y is 7y. 18 minus 4 is 14. So I divide both sides by 7. I get y equals 2.
I don't know, I think elimination's easier.
Yeah.
It depends on the problem.
Substitution's easier.
So I'm going to take this y equals 2 and I'm going to plug it into this top equation. So I get 2 equals x plus 3. Subtract 3 from both sides. And I get x equals negative 1. We did a lot of the same math in these problems. So you can see how some of them look like they're a little bit easier. If I were to have a go-to method, my go-to method, first choice would probably be elimination. Just because it's got less places for me to make mistakes. And so I usually get to that first step and find out what the first variable is without making huge mistakes. Whereas in substitution, you have to do some distributing and things like that sometimes. So sometimes I can make mistakes. So what do you guys think? Do you think elimination is the easiest one?
No, I think substitution in my opinion.
You like substitution?
I like elimination. I like substitution.
Substitution's easier because I understand.
Either one? Does anybody like graphing the best?
It's easier when the graph is there and you don't have to use graph.
Right. If the graph is there, then graphing's not so bad, and if it's set up in slope-intercept form.
Well, no, even setting it up in slope-intercept form is easy.
Okay. All right, so let's look at the next one. When I just look at these equations, the first thing I notice is that the bottom one is not set up in slope-intercept form. So graphing's not going to be my first choice. My first choice, because I do have a variable by itself, is to use substitution. So I'm going to go to the substitution column, and we're going to do substitution first. What's that? We're going to do all of them, but I'm just going to tell you why I chose that one first. If I take this and I put it in here for y, then I have 5x plus 3. Now you have to have the parenthesis. It's x plus 7 equals negative 27. We have to distribute that 3. So 5x plus 3x plus 21 equals negative 27. Combine your like terms. 8x plus 21 equals negative 27. Now to solve this, we're going to subtract 21 from both sides. Since they are both negative, you're adding them together and the answer is negative. Negative 48. And then you're going to divide by 8 and get x equals negative 6. Then I'm going to take this and the original equation and I'm going to go y equals negative 6 plus 7. So y equals 1. So negative 6, 1 is my solution.
Now for me, when graphing, I can still do the graph immediately because I know the steps just to turn it into y.
Right, and we're going to do that. So to me, it was just set up for that. I didn't have to do any other work to get it set up for it. You will have to use the specific method it asks for on your final exam. If it says to use substitution and you don't use substitution, you will not get credit for that. Okay?
That's right.
Even if it's right. I want you to show me that you know how to do it. Now, let's say,
Process than the answer.
yes, definitely more the process than the answer. let's say you do substitution, but you're not super sure about it, and so off on the side you do elimination to see if it's right. That's totally okay. Okay? Yeah, because you're just double checking yourself. But I want to see the process for substitution when I ask for substitution. I want to see the process of elimination when I'm asking for elimination. And I may put some on there that are just, you get to choose.
Yes.
Okay. But there will be ones specific that say, solve this by graphing, solve this by elimination, solve this by substitution.
Will there be any on there with the how we solve it, like the way you showed us yesterday, the new way, where you have to multiply the top x and bottom x too?
There won't be any of those on the final unless it's extra credit. So.
Also, for the final, are there gonna be like word problems for it?
Mm-hmm.
Okay, what type of word problems? How would we do that?
Look, they're in your book.
Are they
Go back a few pages. Go toward the back a few pages.
oh, go towards the. Like,
Yeah, we haven't done them yet.
Oh.
So,
We'll do those next week.
yeah, we're going to do those next week. Okay, so let's look at the graphing. Like you said, Brennan, the first one is set up in slope-intercept form. My y-intercept is 7, and my slope is 1. Up 1, right 1 gives us our slope. If you run out of space, then you can go down and left, because down and left is the same thing as up and right. Now the second equation, I'm going to rewrite that down here. I have to get y by itself. To get y by itself, the first thing we're going to move is the x term. So we'll subtract 5x from both sides. So you get 3y equals negative 5x minus 27. Now we're going to divide everything by 3. We have to do everything. So we end up with this negative 5/3, which at first you might think, oh gosh, that's a fraction, but you know what? It's the slope, so it doesn't matter. And then negative 27 divided by 3 is what? Negative 9. So that means our y-intercept is negative 9, and our slope is negative 5/3. I can't go down 5, so instead of going down and right, I'm going to go up and left. So up 5, left 3, up 5, left 3, and I just do that until I run out of space so that I can graph my whole line. Not my straightest line ever.
It's a line.
It is a line, but if I'm asking you guys to do straight lines, I should try and do a straight line. It's just tedious to get the ruler out on this. So, point of intersection,
Negative 6, 1.
-6, 1. Is that what we got when we did substitution?
Yep.
Awesome. Okay, so now let's take this same two equations and let's do elimination. The first thing you have to do for elimination is you have to make sure everything lines up. Things are not lined up here.
We just use this. Oh, no, we can use slope-intercept.
We could use the ones that we did before, but then we're dealing with fractions. I don't think we want to deal with the fractions. So what I would do is I'm going to subtract x from both sides. So I would have negative x plus y equals 7, and then 5x plus 3y equals negative 27. All I did was subtract x from both sides. So instead of x plus 7, I now have negative x plus y. I have to get the coefficients to be opposites. Do you want to do the y's or the x's? X, so that means I'm going to multiply the top equation by what? 5. All right, so then I rewrite that again. So negative 5x plus 5y equals 35. The bottom doesn't change. So I have 5x plus 3y equals negative 27. Add straight down, the negative 5x and the 5x cancel. 5y plus 3y is 8y. 35 minus 27 is 8. So what does y equal? Then we just plug it back into one of our original equations. So 1 equals x plus 7. So I subtract 7 from both sides so I can solve for x. I got x equals negative 6. So negative 6, 1 is our solution.
Yep.
Did I change your mind?
I don't know.
Your favorite still your favorite?
Yeah.
Okay, I'm okay with that. All right, so I'm going to have you pick your method. You can choose to pick your favorite method, or you can choose to pick your method that you need to work on. And I want you to solve this bottom equation. Just pick a method. We're going to go through and do all 3 of them. So if you get stuck on it, we'll pick up. But go ahead and try and answer that. Nice. When you're finished or you've reached a stopping point, you should make eye contact with me. Okay. By stopping point, like you've gone as far as you can. Because we're going to do them all together, so.
My feelings are, I'm good with graphing and substitution. I'm not great with elimination.
So the whole thing that we're doing for the next few days is just practicing the 3 methods. So, yes.
So on number 3, it's x plus y negative 7. And so x plus y, the y would just equal 1 because that's my number.
The coefficient of y is 1. All right, I think most of you made eye contact with me. So which way did most of you do it? Raise your hand if you did graphing. Okay. Raise your hand if you did substitution. Wow. Okay, and who did elimination?
I tried to do it. It didn't really work.
Okay. Slightly more did elimination than substitution. So I'm going to start with elimination and then substitution, and then I'll do graphing last. Okay? Elimination. I probably would have done this one by elimination because things are already lined up. Did you want to eliminate the X's or the Y's?
I did X's.
You did X's?
I do X.
So what did you multiply?
I don't know.
-6.
Multiplied the top by -6? I totally would have done Y.
Really?
Well, then I'm not multiplying by a negative.
Yeah, just do, let's do Y then.
Okay, I would have done Y. So if you did X, that doesn't mean it's wrong. We should get the same answer. We're just going to solve for different variables in different order. So I'm going to multiply the top by 5 because then I'm not multiplying by a negative and I'm less likely to make a mistake.
Wait.
Oops.
Oh, you do it by X. Okay. Wait, no, you did it by Y.
I multiplied the 5 by everything in the top.
I did -6.
Okay, we're going to get the same answer. We should anyway. So I'm not changing the bottom. Now those Y's cancel out. I got 11x equals -55. So x equals -5. Then I'm going to plug it back in. So -5 plus y equals -7. Add 5 to both sides. I get y equals -2. For those of you who solved it the other way, did you also get that?
My line said meet.
I did.
What?
All right. Well, we'll have to look at that when we get to the graphing. Those of you who did substitution, did you get -5 too? Oh, I forgot a negative. -5, -2? Okay.
I got Y.
Okay. All right, so let's look at substitution. With substitution, this is not a bad choice for substitution. I'm getting all tangled up in the cords here. It's not a bad choice for substitution because we have an x and a y that have coefficients of 1, so we could get either one of them by itself. Do you have a preference? Which one did you get by itself? Did you get it y equals? Okay, so I'm going to subtract x from both sides. Then I have y equals -x minus 7. What did you do? That's elimination. That's elimination, what we did on the other one. All right, so if I do this, I'm going to take this y and I'm plugging it in here for y. So I have 6x minus 5. Now you put the parenthesis in to put your -x minus 7. And that equals -20. So once we have that, we have to distribute. And we have to remember that this is -5 that we're distributing. So we should have 6x.
6x.
Well, the first one is 6x, right? Then -5 times -x is positive 5x. And
Plus 30.
what?
What? It's plus 30. No, it's 35. Oh, 35, yeah.
And I'm not there yet
Why?
Yeah, why not?
because I brought the 6x down and then I multiplied the -5 times the -x.
Yeah, and then
Yeah, the negative
you have to do it by
5.
Okay,
-7.
which is
and that's what I'm going to do next. But I just wasn't there, and you guys made me feel like I did something wrong here. So I thought you thought I did something wrong. Okay, -5 times -7 is positive 35. That equals -20. Combine like terms. 11x plus 35 equals -20. Subtract 35 from both sides. We have 11x equals -55. This looks familiar. So I got x equals -5. The last step is going to be exactly the same. I'm going to take that and the original equation, and I'm going to go -5 plus y equals -7. So I add 5, and I get, excuse me, y equals -2.
There we go.
You see how they're similar? The first steps are a little bit different, but we get down to the same point. Now let's look at the graphing. I'm holding on. Okay. Graphing would not be my first choice on this simply because neither one of them are in slope-intercept form. It doesn't mean that I can't get them into slope-intercept form, but if I had a choice on this, I would not graph it. But let's say we don't have a choice. In order to get that by itself, I'm going to have to subtract x from both sides. So y equals negative x minus 7.
Yep.
What is our y-intercept?
-7.
And what's our slope? Negative 1 over 1. So I'm at negative 7. So my negative 1 slope means I go down 1, right 1, and up and left. So it's a negative sloping line, so you should look at it, it goes down from left to right.
You did drop a negative.
No. Lila dropped a negative?
Why would I drop a negative? She never does that.
I hope you know we're just giving you a hard time, but maybe that's what'll help remember it.
Maybe.
Maybe.
Bullying, yes.
All right, let's do the second one. I think I'm going to rewrite this to start it because there's too much other stuff there. So I need to get y by itself. So I'm going to do what first?
Minus 6.
Minus 6x from both sides, right on. So I have negative 5y equals negative 6x minus 20. Then we're going to do what? Divide by negative 5, and we have to divide everything by negative 5. Which is kind of nice because it changes all these, like the signs all change. So the 5's cancel. We have y equals 6 over 5x doesn't simplify, but 20 over 5 is 4. So b is 4 and m is 6 over 5. So I would not want to deal with that if I was plugging it in into substitution. I would not want to deal with the fractions as my first choice. But we're graphing, so there's b equals 4. 6/5 is a positive one, so I'm going to go up 6, right 5. I ran out of space, so I'm going to go down 6, left 5, and I'm going to draw that line in. And our point of intersection is -5, -2, and is that what we got for all of those?
Yes, mine.
Awesome. So my hope is that we've demonstrated this, you've written all this down so that this can be a good reference for you for the final, and the next several days that we're just practicing this. Next week we are going to do some word problems, but tomorrow and Monday we're just practicing choosing different methods. Okay? If you get done with the triples activity, the homework tomorrow is going to be 6-6, which is doing this. So if you are done with the triples activity, you could get that done and not have homework over the weekend. If you don't get it done, that's fine, because I'm not going to check it till Monday.